What came before the soaring pterodactyls and roaring Tyrannosaurus rex we know so well? The answer is something much smaller and quieter. Roughly 4 billion years ago, the Earth was thought to have experienced the Late Heavy Bombardment. This was a barrage of asteroid debris from the formation of the solar system. The cooling Earth then formed its first crust. 100 to 300 million years later, the Arcane Eon began.
This is the earliest possible time that life could have started on Earth, the beginning of what we call the habitability boundary.
At this time, the planet was relatively smooth. The crust was made up of rock formed from magma with no variation in formation. The Earth was veiled in a dense mixture of water vapor and carbon dioxide, with high percentages of sulfur, phosphorus, methane, and ammonia. The Sun was, by some estimates, 30% less dimmer than it is today. Slowly, water in the atmosphere condensed and triggered torrential rains. The ice from the comets and asteroids during the Late Heavy Bombardment also contributed to the growing oceans.
Back then, only 2 or 3% of the planet's surface was dry land. The rest was covered in oceans.
With the moon still in close proximity, tidal waves reached up to 300 meters tall and caused days to be just 10 hours long. Anaerobic organisms were the first to come about, as they did not rely on oxygen.
Archaean organisms were not yet able to swim. In order to survive, they needed a substrate. That is why the biosphere of the time was a thin, slimy film of not more than a millimeter in width on the bottom of a sour and hot ocean in its coastal area.
This biosphere was confined to a thin coastal area and had a maximum depth of up to 20 meters, as the dense atmosphere did not allow sun rays to penetrate deeper. Mouths of underwater volcanoes also provided habitats to bacteria called chemotrophs. These organisms relied on chemical reactions between sulfur and iron instead of light.
Stromatolites would be the only evidence of life seen with the naked eye. These sedimentary limestone formations were created by primordial microorganisms and may reach up to several meters in height.
However, there was a lack of scavengers and decomposers, which is essential to the evolution of life. At this point, the atmosphere was becoming more favorable. Some bacteria started performing photosynthesis. A billion years later, on the cusp of the PROTEROZOIC eons, it brought what is called the Oxygen Catastrophe.
Anaerobic microbes started to die off, as they were basically poisoned by the oxygen. Meanwhile, the newer, more efficient photosynthetic life began to spread.
Oxygen started to build in the atmosphere. As the greenhouse gas carbon dioxide decreased, so did the temperature. In addition, methane was taken out of circulation by the increasing oxygen. Pulses of icy events were followed by an ice age known as the Huronian Glaciation. It lasted as long as 300 years. The overwhelming amount of oxygen then started to kill the photosynthetic bacteria. But about 2.1 billion years ago, when the Huronian Glaciation ended, the Earth had gained an ozone layer which helped shield the planet from the ultraviolet sun radiation. This beginning of this eon saw many significant geological events.
Alongside the continents, banks of metal ores and new rocks were being formed.
Overall, the Paleozoic Era is known for the rise of the marine life, the development of complex ecosystems, and the evolution of many new types of organisms, including fish, amphibians, insects, and early land plants. It began with the supercontinent in the southern hemisphere called Gondwana.
Pangaea broke up into Laurasia and Gondwana. Laurasia formed the northern continents, while Gondwana broke up into the southern, including Africa and Australia.
The Silurian period, 444 million years ago, saw the first plants near rivers and tidal areas. Simple mosses and lichens were also present. Marine life was slowly expanding, and about 20 million years later, decomposers emerged in the oceans. Millions of years later, the greater part of the tropical zone was covered in ferns, but there were no organisms that would decompose. As a result, dead trees could not pass any nutrients to their descendants.
They remained lying without decaying, and the phosphorus in their bodies, so vital for plants, couldn't be extracted. Thus, with time, lush sappy verdure gave way to enormous heaps of dead wood, covering enormous stretches of land.
These later formed rich deposits of coal for humans. During the Permian period, starting 299 million years ago, marine life had evolved vigorously, and the first amphibians dared to venture onto land. However, the Permian period closed with a mysterious massive extinction event. Scientists estimate that 96% of marine species and 73% of land species died out. Life during the Triassic period took bounds and leaps forward.
Photosynthetic microorganisms quickly spread across the upper layer of the global ocean. Tempted by the food, fishes, mollusks, and arthropods followed it.
Contrary to popular belief, the Earth during the following Mesozoic Era, when dinosaurs thrived, was not solely covered in tropical forests. Equatorial regions were drought-like, while in other areas swamps mingled with the forests. By the end of this period, flowering plants were present and the formation of grass helped stabilize the soil.
By mingling their tiny roots in the ground, they help form and strengthen the turf. This not only makes soil tougher and prevents it from getting washed off or eroding, but also takes care of getting rid of excess water.
With the extinction of dinosaurs, mammals were next to evolve. For the next 66 million years, mammals rapidly diversified and evolved into many different species. Homo sapiens now test the limits of the Earth. Hope you enjoyed this pre-dinosaur episode. Don't forget to subscribe to see more videos like this.